Working effectively with real business data is one of the central challenges in building production AI systems.
Tables are messy, schemas leak through prompts, and agents burn tokens trying to guess intent.
ORMCP is designed to fix those problems.
It gives AI agents a clean, object-oriented, MCP-compliant view of enterprise data, so they reason over business concepts, not raw tables.
So in this explainer, we're going to walk through how ORMCP works, why data modeling is frankly more important than ever for AI systems, and how this idea of token efficiency really changes how these agents behave.
And to make all this concrete, we're going to ground it with a real example, a Smart Inventory Watchdog. This is an AI agent that's constantly monitoring e-commerce inventory, and it does it using ORMCP and a RESTful Gilhari microservice.
The point isn't just this one use case. It's a repeatable architectural pattern for building scalable, production-ready AI applications. Let's dive in.
Something's not right. We've got a critical failure happening deep in the system, and we've been called in to figure out what's going on.
So here's our subject, a top-of-the-line AI agent. Its mission? Simple data retrieval. But look at this. The mission log is flashing critical. The whole system is just bleeding errors.
And just look at this terminal log. I mean, wow. The agent is literally drowning in a sea of raw SQL. It's making up table names, just hallucinating, burning through its token limit like crazy, and bam. Query halted. The mission is completely dead in the water.
All right, let's get into it. This isn't just some simple bug. This is a total catastrophic failure. The investigation starts right now, and first things first, we need to figure out the root cause. And here's the thing. This isn't a one-off. We're seeing this pattern pop up everywhere. These incredibly brilliant AI agents, they just fall apart when they have to talk to old-school databases. So the big question is, what is killing our AI agents? You know, our investigation is pointing to one prime suspect. And it's not a piece of bad code or a faulty server. No, it's something more fundamental, a conceptual barrier. We've started calling it the SQL wall. So what is the SQL wall? Well, it's the heart of the problem, really. It's this deep, fundamental clash between two totally different ways of thinking. See, LLMs think in concepts, objects, ideas, how things are related, but databases, they demand everything in this super rigid format of tables, joins, and really strict syntax.
This slide really lays it all out. A tale of two logics, right? On one side, you've got the AI, totally fluent in objects and natural language. But on the other, the database, screaming for tables and picky syntax. When you force an AI to write raw SQL, you're essentially asking it to forget everything it's good at and try to reason about this complex alien schema. And the result? Well, it's exactly what we saw at the beginning. Inefficient, insecure, and ultimately a broken process.
But you know how it is in every investigation? There's always a turning point. That one piece of evidence that just cracks the whole case wide open. For us, that breakthrough was discovering what's basically a universal translator. And it's called ORMCP. It stands for Object Relational Model Context Protocol. And it's so much more than just a piece of software. It's an open standard. Think of it as that universal translator. Its whole job is to take those rigid database tables and turn them into something the AI understands natively. Objects. It literally bridges that communication gap.
The team behind the ORMCP server project says it best. Their mission is to make your relational data AI ready. That's it right there. It's not about forcing the AI to change. It's about getting the data ready for the AI.
Okay, so we found our solution. Now it's time to pop the hood and see exactly how this translator works its magic.
And the whole process is actually pretty slick. It's a 4-step flow. First, the AI makes a request using a standard protocol, and get this, it never writes a single line of SQL. Then the ORMCP server translates that request into a simple API call. From there, a specialized little microservice called Gilhari takes over and generates the secure, optimized SQL needed. And finally, the database sends back the data as clean, object-oriented JSON, a format the AI can understand without breaking a sweat. It's a super secure and efficient pipeline from start to finish. All right, theory is one thing, but we need some cold, hard evidence. Let's take a look at this Smart Inventory Watchdog. This is an AI agent that was failing spectacularly before. Now we've equipped it with ORMCP. This, right here, is the proof that closes the case.
So here's the prompt we gave the agent. Just a simple natural language request. Show me all users with age greater than or equal to 55. The exact kind of thing that would have sent it into that death spiral of red errors we saw earlier. And here's the result. Look at that perfectly structured, clean JSON. No errors, no weird hallucinations, just exactly the data we asked for. And you know what the best part is? The data shows this whole process can cut down token usage by almost 70%. We've gone from total system failure to a flawless, super efficient execution. So what's the bottom line? Why does this all matter so much? Well, first, security. The AI is basically in a sandbox. It never touches raw SQL. Second, efficiency. No more wasting tons of tokens trying to figure out schemas. The AI just thinks in objects.
Third, standardization. This is an open protocol, which means it's future-proof and works with different databases. And finally, performance. It's all built on a fast, lightweight microservice. It literally solves every single problem we identified at the start of our investigation. Case closed. The agent's mission? It's back online. The system is stable. All those errors are gone, replaced by this, a clean, quiet, ready terminal. The crisis has been averted. We found the solution. It's called ORMCP, and it's what finally tears down that SQL wall. But knowing what works is just the beginning. Now let's crack the hood and see how the architecture actually works. So how in the world do you let a powerful AI tap into your company's most critical data without, handing over the keys to the entire kingdom? That's the big question, right? In this explainer, we're going deep inside the secure blueprint that actually makes this possible. We're going to break down the core engineering that lets AI and databases talk to each other safely and, more importantly, intelligently. All right, last time we got the ORMCP server up and running. Now it's time to go inside. Welcome to the engine room. We're not just looking at a bunch of code here. We are going to dissect the architecture itself, layer by layer, to really understand how it solves one of the single biggest challenges in AI today: secure, efficient communication with our good old traditional databases. Everything, and I mean everything, flows through this 4-layer stack. You've got your AI, the brains of the operation, at the very top. And way down at the bottom, you have the database, the memory. The real magic? That happens right in the middle, with our 2 essential translators, the ORMCP server and the Gilhari microservice. Each one has a very specific job, and together they build this super secure and efficient channel for communication. And that, right there, brings us to the main event, the central challenge. Look, you wouldn't give a brand new employee the master key to every single file cabinet on their first day, would you? Of course not. And it's the same idea here. You absolutely cannot let an AI just browse your database schema directly. It's wildly inefficient and, honestly, a massive security nightmare waiting to happen. So how does the AI figure out what it's even allowed to ask for if it can't see everything? Well, this is the secret sauce. This is the magic tool that makes it all click into place. Before the AI can ask a single intelligent question, it makes one special call: Object Model Summary. You should think of this as the crucial first handshake. It's not asking for any data yet. Nope. It's asking for a map of the data. And this is the key. That map is presented in a clean, object-oriented way. And the difference this one step makes is just night and day. Without that initial handshake, that map, the AI is completely flying blind. It has no clue what a product is or that it might be connected to a supplier. It's totally lost. But with the object model summary, bam, it gets a clean, structured map. It suddenly understands these concepts, and most importantly, the relationships between them. This is the bedrock for any kind of smart conversation. Okay, so let's follow a real request and see how it travels through the system. A user gives a simple natural language prompt to an AI agent, something just like this. Now, the AI has to take this very human request and somehow turn it into something the database can actually work with. And here's the very first translation. Using that map it got earlier, the AI converts that plain English sentence into this structured command. Now, look closely. This isn't SQL. This is a universal language called the Model Context Protocol, or MCP. Notice how it's talking in terms of a class and a filter. This is so important because it's completely database agnostic. The AI has no idea and doesn't need to know if the backend is Postgres, MySQL, or anything else. So that MCP command then travels to the next layer in our stack, the ORMCP server. You can think of this piece as the system's diplomat. It takes that universal MCP command and translates it into a standard REST API call, the language that pretty much all web services understand. This is such a clever step because it creates a buffer, completely decoupling the AI from what's happening on the backend. And now we arrive at the Gilhari microservice. This is our database expert. It takes that REST API call and does the final, most critical translation. Using its powerful object relational mapping, or ORM, foundation, it converts that object-based request into a precise and, I can't stress this enough, a safe SQL query. This is the component that actually speaks the native language of the database, handling all that nitty-gritty schema complexity so nothing else has to. Once the database does its thing and runs the query, the result travels right back up the same chain. Gilhari grabs the data and packages it into this beautiful, clean JSON object. That gets passed back to the ORCNP server and then finally to the AI. The AI doesn't have to struggle with parsing weird database tables. It just gets a simple, ready-to-use object like this. Easy. Okay, let's switch gears and talk about what is arguably the single most important feature of this entire blueprint: security. It all boils down to this one simple, powerful principle. That object relational mapping file, that domain model we keep talking about, it's the ultimate gatekeeper. The AI never, ever gets free reign over your data. And this table shows you exactly how that works. In our mapping file, we explicitly define which database columns connect to which object attributes. So things like product name, yeah, they're visible. But sensitive columns, like a social security number or maybe an internal cost price, we just never map them. They literally don't exist in the AI's version of the world. So it's physically impossible for the AI to ask for them, let alone see them. So let's just boil this all down. What makes the setup so powerful? First, abstraction.
It hides all the messy database details. Second, standardization. It uses that open MCP protocol, so everyone's speaking the same language. Third, security. Access is controlled by the model, not by the AI. And finally, efficiency. The AI gets a tiny little summary, not the entire heavy, raw schema. If we had to point to just one component and say, that's the key, it would be this one. The Gilhari microservice truly is the heart of this entire operation. It's the secure engine that does the translation. It's the guard at the gate for all your data. It's really what makes the whole system so robust and reliable. So there you have it. You've seen the complete blueprint for how this revolutionary connection actually works. The real question is, are you ready to build one yourself? Because in our next explainer, that is exactly what we're going to do. We will walk you through, step by step, building your very own Gilhari microservice from scratch using a real-world e-commerce database. Trust me, you are not going to want to miss it.
All right, let's jump right in. Today, we are stepping into the workshop and we're going to build something amazing, a bridge that connects pretty much any traditional database to the world of AI. And the best part, we're going to do it in minutes, not months. Okay, time to get our hands dirty. So look at this. On one side, we've got this incredibly valuable asset, a pretty complex relational e-commerce database. It's packed with all this interconnected data that, makes the business run. And on the other side, a totally blank project folder. So here's the challenge. How do we unlock all that siloed data and build an AI-ready microservice for it fast? Because in today's world, speed is everything. Waiting weeks for a team to manually code this stuff, that's just not going to fly.
So where do we even start? Well, that's the trick. We don't. We let automation draw the map for us. This first phase is all about creating the blueprint, automatically taking that raw database schema and turning it into clean, usable code. No human intervention needed.
Now, just to be clear, we're not talking about some simple flat table here. We're working with a real-world Postgres schema, and it's got 6 core entities. You've got suppliers, products, customers placing orders, orders containing items. It's a really complex web of relationships. Trying to map all this out by hand would be a total nightmare, just begging for errors.
But of course, we're not going to do it manually. The absolute key to this whole operation is a single, super powerful script. With this one command, we kick off a process called Smart Reverse Engineering. It just dives right into our existing database and
automatically figures out the entire object model structure for us from just the specified tables.
It's kind of like magic. And here is the absolute best part. To get from that super complex schema to a fully functional object model requires, zero manual coding, none.
The script analyzes all the specified tables,
the columns, the foreign keys, the whole shebang, and generates everything we need to represent that data inside our application. All right, with our blueprint in hand, we are ready for the assembly line. The next step is to take all these generated files and build our final deployable product. And trust me, this part happens almost instantly.
So, just like the blueprint phase, the deployment is completely automated with another script, buildall.sh. This thing is basically our digital assembly line. It runs the reverse engineering we just talked about.
It compiles all the object model classes it generated.
It builds a lightweight Docker image, and then boom, it deploys it as a running container. It's a whole 4-step process, all executed with just one command.
Now, you might be sitting there wondering, how on earth can this happen so fast? Well, the secret is we're not building everything from scratch. Our application is built on top of a pre-configured base image called SoftwareTree/Gilhari. It basically containerizes the entire data layer for us, so all we have to do is drop our specific blueprint right on top.
And the result of all this? It's just staggering efficiency. By automating the blueprint and building on this pre-made foundation, we go from a raw database schema to a production-ready microservice in literally seconds. This is how you really accelerate development and get your AI features to market faster. And just like that, it's done. Our Gilhari microservice is live, it's up, it's running, and it's serving our e-commerce data through a clean, modern REST API. But, serving data is only half the story. The real magic is making it talk to AI. This brings us to the real aha moment of this entire process. Okay, so we have our data service, but how do we plug it into an AI model like Claude or ChatGPT? Well, we need a universal connector for AI. And that connector is the ORMCP server. Now, ORMCP stands for Object Relational Model Context Protocol. It's basically a translator. It speaks a language called MCP, the Model Context Protocol, which is an open standard designed specifically for how AI models talk to external tools. This server lets any AI that understands MCP communicate directly with our brand new microservice. The easiest way to think about it is like a universal adapter for your data. Your database has its own specific plug, right? And the AI models have theirs. The ORMC server is that magic piece that fits perfectly in between, allowing any compliant AI to connect to your data source without any custom wiring. It just works. Okay, so the theory is great, but let's get to the payoff. It's time to go live and actually connect our freshly built microservice to some of the most powerful AI platforms on the planet. Now, there are 2 main ways we can do this. For a local tool, something like Claude Desktop, we can make a direct connection just by telling it where our ORMCP server is running on our machine. But for a remote, web-based agent like a custom GPT, we just need to expose our local server to the internet using a secure tunnel. So let's start with Claude. And look how ridiculously simple this is. You just open up a single configuration file, claude-top-config.json, and you add this little block of code. You give it a name, you point it to the ORMC server command, and then, most importantly, you set one environment variable that tells it the URL of our running Gilhari microservice. That's it, you're done.
Connecting to ChatGPT is just as straightforward. Seriously. First, you start the ORMCP server in HTTP mode. Then, you use a cool little tool like ngrok to create a secure public URL that points right to your local machine. You take that URL, you add /MCP to the end of it, and you just paste that final address right into your custom GPT's configuration settings.
And with those few simple steps, the bridge is live. The agents are plugged in. Our Docker container is serving up the data, and both Claude and ChatGPT are fully connected and ready to start interacting with it.
So, we've actually done it. We took a standard, totally isolated relational database, and we've transformed it into a modern, AI-accessible asset. It is officially AI-ready, capable of understanding and responding to natural language queries through the world's most advanced AI models.
I mean, this process just unlocks a whole universe of possibilities. Think about building intelligent inventory watchdogs or creating AI-powered analytics dashboards that can practically see around corners. We've just given a voice to a silent, incredibly valuable asset. And so that leaves us with one final, really exciting question. Now that your data can talk, what are you going to ask it?
All right, we've talked about the theory, we've looked at the tools, but now it's time for the main event. We are putting it all together, right here, right now. We're going live to see a fully autonomous AI agent do its thing, making real-time decisions with actual enterprise data. Let's see what happens. Okay, so what you're seeing is our Smart Inventory Watchdog in its natural habitat. It is live, it's plugged into an e-commerce database, and its mission is pretty simple. Keep things in stock and keep the inventory lean. And the key here, it isn't just sitting there waiting for someone to ask it a question. No, it's on the hunt, actively looking for problems to solve.
And speak of the devil, it looks like it didn't take long at all for our watchdog to sniff something out. Let's zoom in and see exactly what problem it's found, and more importantly, how it's going to fix it all by itself. Aha, there it is, our first hit. The inventory for the Spectre X1 laptop just dipped to 48 units, which is just under that critical reorder threshold of 50. Now, in your typical old school system, this would just, send a boring little email. But this is where our AI agent really starts to show off. So how does it do that? What's the secret sauce behind that intelligent response? Let's pop the hood and take a look at the anatomy of the AI agent built for this exact job. Look, we need to be clear, this isn't just some simple script running on a timer. It's a genuine AI agent. It doesn't just see that the stock is low, it's designed to understand why. It's not just flagging a number, it's looking at sales patterns to actually predict future demand. That's a huge difference. And here's a simple way to think about how it's built. You've got the brain, that's lang chain, which handles all the smarts, the reasoning and decision-making. Then you have the senses, and this is so important. These are the ORMCP tools. They let the agent securely see and touch the database. But here's the kicker. It's not seeing messy SQL. It's seeing clean, simple objects. And finally, it has a voice, a basic notification tools to tell the rest of us what it decided to do. Okay, so we know how it's built. Now for the fun part. Let's watch it actually think. This is the autonomous decision-making process happening right now. All right, so the agent knows the stock is at 48. A person in this spot might just go, order another 100. But how does an AI make a truly smart, data-driven call? What does it do next? First things first, it doesn't just take the alert at face value. It verifies. It uses its query products tool to ask the database directly, hey, show me everything with stock below 50. Boom. This confirms the problem and gets it the complete data object for that laptop. Okay, now this is where it gets really cool. This is the big brain move. Instead of just picking a random number to reorder, it uses the get aggregate tool to figure out sales velocity. It's literally asking, how many of these laptops did we sell in the last 90 days? That's how it's going to predict what we'll need next. And there's the answer, 112 units. See? That's not a guess. That's not a gut feeling. It's a precise, calculated number based on what's actually been happening. That right there is what an AI-driven approach looks like. And done. Mission accomplished. In the span of a few moments, the agent confirmed the problem, calculated the exact solution, and fired off an alert to the supplier. All of it completely on its own. No human needed. So, we've seen the what. Pretty impressive, right? But now let's talk about the how. What's the magic under the hood that makes this kind of autonomous action even possible? It really boils down to these 4 key pillars. First, speed. What we just saw was near instant, thanks to a super optimized engine. Second, security, which is absolutely non-negotiable. The AI never got the keys to the whole kingdom. It only saw the specific safe data objects it was given permission for. Third, object abstraction. This is huge. The AI was thinking about products and orders, not tangled up in complex SQL. And finally, token efficiency. Those simple, direct calls are way more concise than writing out a long-winded question, which makes the whole thing faster and a lot cheaper to run.
And this right here, this really puts it all into perspective. The old way meant you had a terrible choice. Either you expose your entire database to an AI, yikes, or you waste time building clunky, fragile middleware. ORMCP is the new way. It gives you a third, much better option. A secure, efficient object layer that lets your AI play with your data safely and, well, intelligently. So when you step back and look at all this, what's the big picture? It's that ORMCP is way more than just another tool. It's a fundamental shift in how we think about getting our data ready for the AI revolution. You know, for decades, our most valuable asset, our data, has been locked up in these relational databases, basically inaccessible to modern intelligent systems. Our MCP server is the key. It's the bridge that finally connects that legacy of data to the future of AI. It's what lets you finally unlock all that potential. Listen, what we just saw with the Watchdog agent, that's not just a cool demo. That's the start of a whole new standard for enterprise AI. The era of the SQL-blind AI is over. Your data is finally AI ready. Thanks for joining us on this deep dive.